Engines intended for high RPM use, a multi-piece eccentric shaft may be used, allowing additional bearings between rotors. While this approach does increase the complexity of the eccentric shaft design, it has been used successfully in the Mazda's production 3-rotor 20 BREW engine, as well as many low-volume production race engines. The C111-2 4-rotor Mercedes-Benz eccentric shaft for the KE Series 70, Type DBM 950 KE409 is made in one piece. Mercedes-Benz used split bearings. Motorcycle engines. Norton Interpol 2 prototype. The small size and attractive power-to-weight ratio of the Wankel engine appealed to motorcycle manufacturers. The first Wankel-engined motorcycle was the 1960 IFA/MZ KKM175W built by German motorcycle manufacturer MZ, licensed by NSU. 127. In 1972, Yamaha introduced the RZ201 at the Tokyo Motor Show, a prototype with a Wankel engine, weighing 220 kilograms and producing 60 HP, 45 kilowatts, from a twin-rotor 660cc engine, U.S. patent N3964448. In 1972, Kawasaki presented its two-rotor Kawasaki X99 rotary engine prototype, U.S. patents N3848574 and 3991722. Both Yamaha and Kawasaki claimed to have solved the problems of poor fuel economy, high exhaust emissions, and poor engine longevity in early Wankels, but neither prototype reached production. In 1974, Hercules produced W2000 Wankel motorcycles, but low production numbers meant the project was unprofitable, and production ceased in 1977. 128. From 1975 to 1976, Suzuki produced its Re5 single-rotor Wankel motorcycle. It was a complex design with both liquid cooling and oil cooling, and multiple lubrication and carburetor systems. It worked well and was smooth, but being rather heavy, and having a modest power output of 62 HP, 46 kilowatts, it did not sell well. 129. Dutch motorcycle importer and manufacturer Van Veen produced small quantities of a dual-rotor Wankel engine OCR 1000 motorcycle between 1978 and 1980, using surplus Komotor engines. The engine of the OCR 1000 used a repurposed engine originally intended for the Citroën GS birotor car. 130. In the early 1980s, using earlier work at BSA, Norton produced the air-cooled twin-rotor Classic, followed by the liquid-cooled Commander and the Interpol 2, a police version. 131. Subsequent Norton Wankel bikes included the Norton F1, F1 Sports, RC588, Norton RCW 588, and NRS 588. Norton proposed a new 588cc twin-rotor model called the NRV 588 and a 700cc version called the NRV 700. 132. A former mechanic at Norton, Brian Crichton, started developing his own rotary-engined motorcycles line named Roton, which won several Australian races. Despite successes in racing, 133. No motorcycles powered by Wankel engines have been produced for sale to the general public for road use since 1992. The two different design approaches, taken by Suzuki and BSA, may usefully be compared. Even before Suzuki produced the Re5, in Birmingham, BSA's research engineer David Garside was developing a twin-rotor Wankel motorcycle. BSA's collapse put a halt to development, but Garside's machine eventually reached production as the Norton Classic. Wankel engines run very hot on the ignition and exhaust side of the engine's chokewood chamber, whereas the intake and compression parts are cooler. Suzuki opted for a complicated oil cooling and water cooling system, with Garside reasoning that provided the power did not exceed 80 HP, 60 kilowatts, air cooling would suffice. Garside cooled the interior of the rotors with filtered ram air. This very hot air was cooled in a plenum contained within the semi-monocoque frame and afterwards, once mixed with fuel, fed into the engine. This air was quite oily after running through the interior of the rotors, and thus was used to lubricate the rotor tips. The exhaust pipes become very hot, with Suzuki opting for a finned exhaust manifold, twin-skinned exhausted pipes with cooling grills, heat-proof pipe wrappings and silencers with heat shields. Garside simply tucked the pipes out of harm's way under the engine, where heat would dissipate in the breeze of the vehicle's forward motion. Suzuki opted for complicated multi-stage carburation, whilst Garside chose simple carburetors. Suzuki had 3 lube systems, whilst Garside had a single total loss oil injection system which was fed to both the main bearings and the intake manifolds. Suzuki chose a single rotor that was fairly smooth, but with rough patches at 4,000 rpm. Garside opted for a turbine-smooth twin-rotor motor. Suzuki mounted the massive rotor high in the frame, but Garside put his rotors as low as possible to lower the center of gravity of the motorcycle. 134, although it was said to handle well, the result was that the Suzuki was heavy, overcomplicated, expensive to manufacture, and, at 62 bhp, a little short on power. Garside's design was simpler, smoother, lighter and at 80 HP, 60 kilowatts, significantly more powerful. 135, aircraft engines. In principle, Wankel engines are ideal for light aircraft, being light, compact, almost vibrationless, and with a high power-to-weight ratio. Further aviation benefits of a Wankel engine include Wankel RC2-60 aeronautical rotary engine ERF Super 2 with the British Midwest A110 twin-rotor Wankel engine Diamond the 20 with the Diamond engines Wankel Sikorsky Cypher unmanned aerial vehicle, UAV, powered with a ULA 801 Wankel engine 1. Rotors cannot seize, since rotor casings expand greater than rotors. 2. The engine is less prone to the serious condition known as engine knock, which can destroy a plane's piston engines in mid-flight. 3. The engine is not susceptible to shock cooling during descent. 4. The engine does not require an enriched mixture for cooling at high power. 5. Having no reciprocating parts, there is less vulnerability to damage when the engine revolves at a higher rate than the designed maximum. The limit to the revolutions is the strength of the main bearings. Unlike cars and motorcycles, a Wankel aero engine will be sufficiently warm before full power is asked of it because of the time taken for pre-flight checks. Also, the journey to the runway has minimum cooling, which further permits the engine to reach operating temperature for full power on takeoff. 136. A Wankel aero engine spends most of its operational time at high power outputs, with little idling. This makes ideal the use of peripheral ports. An advantage is that modular engines with more than 2 rotors are feasible, without increasing the frontal area. Should icing off any intake tracts be an issue, there is plenty of waste engine heat available to prevent icing. The first Wankel rotary engine aircraft was in the late 1960s, being the experimental Lockheed Q-Star civilian version of the United States Army's reconnaissance QT-2, essentially a powered Schweizer sailplane. The plane was powered by a 185 HP, 138 kilowatts, Curtiss-Wright RC2-60 Wankel rotary engine. The same engine model was also used in a Cessna Cardinal and a helicopter as well as other airplanes. 120, 137, 138. In Germany in the mid-1970s, a pusher-ducted fan airplane powered by a modified Nsu multirotor Wankel engine was developed in both civilian and military versions, fanliner and fantrainer. At roughly the same time as the first experiments with full-scale aircraft powered with Wankel engines, model aircraft-sized versions were pioneered by a combine of the well-known Japanese O.S. engines firm and the then extant German Groupieraro modeling products firm, under license from NSU/Auto Union. By 1968, the first prototype air-cooled, single-rotor glow-plug ignition, methanol-fueled 4.9 cubic centimeters displacement LS/Groupner model Wankel engine was running, and was produced in at least two differing versions from 1970 to the present day, 139, solely with OS firm after Groupner's demise in 2012. 140. Aircraft Wankel engines are increasingly being found in roles where the compact size, high power-to-weight ratio and quiet operation are important, notably in drones and unmanned aerial vehicles. Many companies and hobbyists adapt Mazda rotary engines, taken from cars, to aircraft use. Others, including Wankel GmbH itself, manufacture Wankel rotary engines dedicated for that purpose. 141, 142. One such use is the Rotor power engines in the Mollusk M400. Another example of purpose-built aircraft rotaries are Austro engines 55 HP, 41 kilowatts, A50R, certified, and 75 HP, 56 kilowatts, A75R, under development, both are per 2 HP/kilogram. 143. Wankel engines have been fitted in home-built experimental aircraft, such as the ARV Super 2, a couple of which were powered by the British Midwest Aero engine. Most are Mazda 12AM and 13B automobile engines, converted to aviation use. This is a very cost-effective alternative to certified aircraft engines, providing engines ranging from 100 to 300 horsepower, 220 kilowatts, at a fraction of the cost of traditional piston engines. These conversions were initially in the early 1970s. With a number of these engines mounted on aircraft, as of the 10th of December, 2006, the National Transportation Safety Board has only 7 reports of incidents involving aircraft with Mazda engines, and none of these were a failure due to design or manufacturing flaws. Peter Garrison, contributing editor for Flying Magazine, has said that, in my opinion, the most promising engine for aviation use is the Mazda rotary. 144. Mazda rotaries have worked well when converted for use in home-built aircraft. However, the real challenge in aviation is to produce FAA-certified alternatives to the standard reciprocating engines that power most small general aviation aircraft. Mistral engines, based in Switzerland, developed purpose-built rotaries for factory and retrofit installations on certified production aircraft. The G190 and G230TS rotary engines were already flying in the experimental market, and Mistral engines hoped for FAA and JAA certification by 2011. As of June 2010, G300 rotary engine development ceased, with the company citing cash flow problems. 145. Mistral claims to have overcome the challenges of fuel consumption inherent in the rotary, at least to the extent that the engines are demonstrating specific fuel consumption within a few points of reciprocating engines of similar displacement. While fuel burn is still marginally higher than traditional engines, it is outweighed by other beneficial factors. 146, 147. at the price of increased complication for a high-pressure diesel-type injection system. Fuel consumption in the same range as small pre-chamber automotive and industrial diesels has been demonstrated with Curtiss-Wright stratified charge multi-fuel engines, while preserving Wankel rotary advantages. 148. Unlike a piston and overhead valve engine, there are no valves which can float at higher RPM, causing loss of performance. The Wankel is a more effective design at high revolutions with no reciprocating parts, far fewer moving parts and no cylinder head. 149. The French company Citroën had developed Wankel-powered Re2 helicopter in the 1970s. 150. Since Wankel engines operate at a relatively high rotational speed, at 6,000 rpm of output shaft, the rotor makes only 2,000 turns. With relatively low torque, propeller-driven aircraft must use a propeller speed reduction unit to maintain propellers within the designed speed range. Experimental aircraft with Wankel engines use propeller speed reduction units. For instance, the Midwest twin-rotor engine has a 2.95:1 reduction gearbox. The rotational shaft speed of a Wankel engine is high compared to reciprocating piston designs. Only the eccentric shaft spins fast, while the rotors turn at exactly 1/3 of the shaft speed. If shaft is spinning at 7,500 rpm, the rotors are turning at a much slower 2,500 rpm. Pratt & Whitney Rocketdyne has been commissioned by DARPA to develop a diesel Wankel engine for us in a prototype TOL flying car called the Transformer. 88, 89, 90, 91. The engine, based on an earlier unmanned aerial vehicle Wankel diesel concept called EnduroCore. 92. The sailplane manufacturer Schleicher uses Nostro engines A50R Wankel. 151, 152. In its self-launching models ASK 21Me, ASH 26E, 153. ASH 25M/me, ASH 30Me, ASH 31Me, ASW 22BLE and ASG 32Me.
Yes, that's something I like to read. The sailplane Schleicher ASK-21. I did flying a glider sailplane when I was a teenager. The ASK-21, but not with engine. We use it at schooling glider. Sail, of course, not a glider. They call it a sailplane. So, but look at that. All this. Look at all this later. I need to make a new read list.
In 2013, Ego Aeroplanes, based in Cambridge, United Kingdom, announced.
Yes, the video is to split in 1 minute. So, just need something to drink and get off my bed a little bit. Cannot read this finish because we have recorded 2 hours. We don't have, and it's 4 p.m. Yes, we can read it finished, but we need to charge the camcorder. I think we should read 20 more minutes. Then I have to start to upload this part. This 6 parts. There's 7 parts. 7 parts, and then start to upload. Then I take a break. I will cook some soup, or heating some soup, but I like to add some pasta. I have some very good potato soup, some very good creamy potato soup. It's like a sauce, so I will cook some pasta. I will cook some pasta I have here and put down the soup. So I can do that when I'm charging the camcorder. And now the video have split, but sometimes I need to get up a bit and stretching my body a little bit. So So I need to make a new read list, but let's do it when I'm finished. No, there's a lot of stuff I like to read about there, and just say that will take many months